So hello, my name is Jeppe. I'm a senior developer at Systematic in Denmark. Recently we've been creating a offline first solution for a new care record system, the next generation of care record systems in Denmark, and hopefully soon the rest of Europe. And that I'm going to tell you about today. So, I'll start off with a short introduction to what these care record system is and why we're doing them. The incentive for it being offline first solution. Then I'll present some of online first just to show you the difference. I'll present our solution, what design implications is tied into this solution, the general learnings that we had, and then I'll let you get some links to other solutions for this offline first. So, as I said, we are developing the next generation care record system. For those of you who don't know what a care record system is, it's sort of like a healthcare record system, but for care for people in their homes. So if they are ill or elderly, they will get care in their homes from nurses and other assistants, in Denmark at least. Compared to the last generation, these new generation is based on tablets, so you carry those to the homes of the elderly and the ill, and you can care and document whatever you do at that home with this device. So the point here is to get closer to the citizen and make a little closer collaboration with them in order to make your documentation, and you can show them what you have documented and stuff like that. So, why should this be an offline first solution? Well, first of all, the customer required it in the requirements, so that's a big thing to do. But this is the reception where Systematic is located in Denmark, and the first one is, let's do back up here. The first one is most of Denmark. And the second one is the outdoor reception in Aarhus, around where we have our office. And the last one here is the indoor reception. So the white dots and the light blue dots are actually not called a reception, I guess. So there's really no connection. So whenever you get inside, there's not really the reception that they promise you to be. So what do we do about that? Well, we go offline first, but let's take a look at what we thought about when we first got this problem. So, of course, the dumb one, just do as we always do, just let it be online when it's online. If it's offline, well, then you can't do anything. But the first thing that came into our heads was, well, we should maybe cache some stuff when we are offline. But how to detect that you're offline? There's a lot of things with the connection. Is it just a very, very weak connection, or is it a good connection? Or is there no connection at all? So the no connection at all is quite easy to figure out, because the device will tell you. But if it's a connection that actually has some throughput, that's a different deal. But let's look at what it would look like in our minds, at least when we thought about this solution. So the user enters some data into a form, presses save. We are checking if we are, maybe we could check here if we were had a connection at all, and that would lead to the same thing as here. But if this is a bad connection, well, then we'll just time out and we go down here as well. But if it was a good connection, well, we'll save the data on the server, return to the user to the overview, fetch the data from the overview, we'll fetch that online. It's successful, we display the data, and the user can see what he entered. That's a good deal. So, but as you can see, there's a lot of branches here. So how do we do this local cache? Well, that's a completely different thing that I won't talk about today, but there's a lot of issues there. But we could save some to a local cache, return the two users to the overview. Again, if we lost connection between here and here, then we will time out or have the same branch as we talked about up here, where we could go offline and say, okay, there's no connection, put it in, take it in the cache, and then maybe we didn't update the cache correctly or whatever we could do. We can show an error, But if it's good, then we just display the data, and that's okay. But as you can see, it's a quite complex way through the code. So, what we thought about, well, make it the first class citizen of the solution. So let's say we're always offline, and that's what kind of became our slogan at the developer team. We store the data in a local database, which is an SQLite for Android. We have push notifications from the main server to push whatever the other users typed in at the other houses. This is quite relevant because the citizen could have multiple visitors from different kind of personnel, so this information should be shared. So you know what's up today, when did they have their medication or what. Then we perform the search against the local database and not the server. So actually we have implemented the logic for searching against a whatever overview kind of what data you need to display for the user. Well, we actually implement that both on the device and on the app server. Because the solution we have also have a web solution, so we can switch in our small wrapper that this is online or offline, and then we'll go again to the local database. So the flow here looks kind of like this. So again, the user enters some data, presses save, we save this to a local database. We ping our synchronization service and say, okay, we have now saved some more data to our synchronization table. This will run asynchronously and the user won't notice. So we then return to the user overview, to the overview with the users, fetch the data from the local database, and we are happy. So not a lot of branches here, actually none. So it's a much more simple and easy way through the code. So the key elements of this solution. So we have some initial synchronization of what's relevant for this user. We need to, let's back up a thing there. So in order to make it possible to have the data that you need on the device, you need to have some sort of relevance criteria and say, okay, this data I will probably access today, so I need this on the device, because the actual database is multiple terabytes, so we can't load that onto a tablet. Whoops. So whenever the user logs in, based on his login and his role and who he has in the system and where he logs in the organization hierarchy, he will get some relevance criteria set up for that, and then the relevant citizens and the relevant data related to the citizen will be synchronized to the device. Then we also have some synchronization of semi-static data. This will be, for instance, the organizational hierarchy or classification data or other users of the system that we need to be able to choose from pick lists and stuff like that. Then, as I said before, this is an SQLite. We do some CRUD and some search against this. And this last one is actually quite important. So in order to keep the versioning and the history of whatever the user has been doing, we actually keep a command stack instead of just the last known entry. So this will make sure that whenever we replay this command stack from our local database and sync it to the server, we actually do each step that the user did. So if we have some states between each of the that are illegal to make, maybe you can't go from open to deleted. Maybe you have to close it first and then delete it. So to make sure that this won't get rejected when it gets sent to the server, we make so that, okay, you actually say close the one first and then you deleted it, and then it will be the same on the server as we did on the device. Yes, and the other element here was the push. So connected to the relevance criteria, you actually also subscribe to the relevant citizens and the relevant data that you need during the day. So you get the push notification from those things. We made it area-based, so we don't have to refresh the entire app each time you get a push notification. So you can say, okay, this is changes to the patient's, the citizen's medication. So we'll just have to refresh the medication overview. Yeah, and we store these in a local database as well in order to make sure that we can have the correct ordering again. So, for instance, if we get some merge conflicts, which is the last element here, then we want to have them to control them up front, and then afterwards we'll take the new data that's pushed to the device. So yeah, the last one here is merge, because I guess it's not really related to offline, but it's just more visible when it's offline, because you can easily provoke some merge conflict. However, whenever you have a lot of users, you will at some point need to handle some merge conflicts if they work on the same data. And in order to minimize this and make it more robust for the user, we try to do this automatically with doing a field-by-field, what's called merging. So if a user changes on two different users change two different fields on an entity, yeah, well then we'll just merge it and we'll take the last one from each of the users. But in case there's an unresolvable conflict, well then we'll display that to the user on the device, and they can get to choose, go into the form and just choose for the field that's actually have a conflict, which one they want to choose. Okay, so what's the good and the bad about this? Well, the bad thing is definitely that we have to make some restrictions in order to make good performance on the device. So this comes back to that relevance criteria. And that could be quite a task to define how should this look like, because what we've done is basically look at some statuses of each entity, some time frame, and some references to other entities if this is something that we need to synchronize. But of course, this also makes some design restrictions for the overviews you can make. So if you don't have all data in the system, well then it's hard to show some big overviews from a lot of organizational data that the customer might want to have, and then we need maybe to do some online thing there and make an online view for that. Then we have this one, and that's actually could have been the good, the bad, and the ugly. Then this would be the ugly, because we have this long login time, and especially for our system, where it's a care record system, where a lot of users log in at the same times when they go to work. Not only are we taking a long time to do this because a lot of data need to be transferred, but also they do it at the same time. So that will be quite a pressure on the app server. And then the last one here is increased complexity, and I guess that's everywhere, because every time you need to do something, make something transparent and look easy for the user, well then there's definitely going some complex thing on in the background. And for this, it was the relevance criteria, but also you need to do a lot of synchronization code. You need to do a lot of, when is this here, and what about the push notifications? We did need them the same way before. We can just refresh our overview from the server, and we had the latest data. We don't need to implement push. So it adds a lot of new complex components to the solution. But the good thing, we're actually able to work offline. I think actually one of our users that used the customer system said it actually works, and that's always a big clap on the back, I guess, when you're a developer. Very nice to hear. Then this one is actually very nice as well, because you have better perceived performance, because you won't ever see if there's no connection or bad reception, because it will just put it in the queue, and sometime it will asynchronously sync to the server. But whenever you save something, it's just saved to the local database, and that's the same, basically the same time every time you do that. So it will always have the same performance, no matter how many clients are on the system, no matter how your reception is, and that's very nice for making a good and robust system. So this one, I guess that's my biggest thing. There's just one way through the code. We do the same thing each time. So if a data saves something, well, we do the same thing. We save it to the local store, we try to put it to a server, and we display the data later. In the other case, well, as I showed before, there's a lot of branches. And that actually takes me to a slide here that what can we in general learn from this, from what we learned. So I think one important thing as a developer is to say, okay, can I make my special case the general case? So I guess this is true for streaming as well. I think that's a good example of this. So if you're doing streaming and you just sit at your desk developing, you have a good internet connection every time you use this. And you say, okay, there's internet connection. Maybe I need to buffer a little bit just to know what I have to show next, but I definitely don't have to buffer much when I start the stream. But then you go outside and you figure out, okay, there's actually such a thing as bad reception. And then you have to handle that, and that will probably be, okay, I probably need to buffer some more. And then you're taking your special case that is you don't have any reception, which is especially a special case if you're sitting at a developer's desk, because then you have all the good conditions. So, yeah, I think that's the point. What we have here is that, okay, we can minimize the amount of dead code. Well, not technically dead, but dead for the developer and untouched areas of the application. It makes it a lot easier to debug, because we only have this one way through the code, so you don't have to look at several different branches. And this could in turn decrease the test effort for the testers. So if you have making some test design, then you have to have a bullet on that test design that says, okay, you should check if this functionality works offline. And then the developer will scratch his head and say, okay, I actually forgot about that we have an offline thing, and I didn't develop that. And then they have to go back in the loop, and we all know that's a costly thing. While we were doing this, we started developing quite some time ago. Some new frameworks have actually popped up. So we have this Realm.io, which is a full platform actually for doing this offline thing. They have this Realm mobile platform, which covers a server with a synchronization thing and what's called a object database on the server, and then we have this object database for the mobile, which actually is so that's equivalent to our SQLite in our case. I think we're actually discussing changing to this Realm.io mobile database, because it should be quite fast. We haven't tested it yet, but that's free and open source. However, this mobile platform is a subscription thing, I think. So you need to look into that if you need that. Then there's also this thing called Redux Offline, which is offline first framework for React Native. So if you're doing React Native apps, well, then this is something to look at. But I guess they mostly look at the same thing as that I have looked at. So how do you have this online data, that offline data store on the device, and how can you make synchronization work with this? Yeah, that's actually it for my presentation. I would love to answer some questions if there are anything about this.
Well, unfortunately, we are out of time as we are a bit delayed. But as I ask others, I think the lounge is a very good place for you to spend some time there, and people can approach you for questions. Yeah. Thank you so much.
Yep, great.